Okay, so as you know, we are trying to jiggle between two different topics, the Redfish part and the boot coordination. Last time we did the Redfish, this time we're going to do boot coordination. And the next meeting, we are going to return to the Redfish part. Now it's been a while since we discussed it. So let me go over it rather quickly.
Before we
Yeah.
dive into this synchronization, Gal, just on the Redfish part, I just want to remind people, like, we started the page. We hope this page will become a fully spec. So I do encourage people to put comments, pull requests. We do want this to become a fully Redfish spec, and I don't see a lot of contribution there. So I just want to remind people. Posted the link in the chat. So while today we're discussing the boot synchronization, that's completely fine, but we do need to ramp up on the life cycle of Redfish spec and interface. So either, NVIDIA, Intel, I know you're already doing a lot of Redfish work. I know servers, Dell, Reza, HP, and others doing a lot of Redfish work. Red Hat doing a lot of Redfish. So please jump in, review the start of the page that we have, add what you think is missing. But we want this to become a fully fledged spec. And according to the Slack discussion that we have today with Summer from ARM, he's going to help us to create a profile that we can actually, the JSON file of profile compliant for DPU, so we can actually test and verify compliance of this Redfish spec that we're going to define from the existing commands and fields.
Thanks for that, Boris. Really. First of all, I didn't hear that we actually didn't read the Slack thread that you had with Samar yet, so that's good to know. And yeah, we'll definitely go over it on NVIDIA and see what we can promote there, and for what we have currently.
Exactly, and maybe even putting a kind of demo or example if NVIDIA already have a Redfish spec working, so we can see, okay, this is working already. We can post some either command line options, how you can do lifecycle with NVIDIA and post a demo video or even the text demo.
I think the problem is that this is a well-walked path amongst tooling out there, and either OPI itself is going to create its own special tooling for use to handle this, or people are going to use the tooling that they already use in their environments. So I think that there's a decision that has to be made amongst contributing entities. Do we wish OPI to do all this, or do we just need to ensure? Are we just trying to ensure there's an open contract that people can adhere to? And if there are already tools out there that are doing that and people are using them, then is there really a need to demo or even have example commands of how to do it? I guess is the question that I would start wondering.
I think if you ask me, Julia, I fully agree that if open source tools or ecosystems already exist, we don't need to reinvent the wheel. But I myself find always useful to have the initial examples, commands, and demos. We can then remove them, but at least it helps initially with having nothing versus having something. And then we can remove the examples and point to existing tools. But for me, I think the most difficult always in this type of communities is to start and ramp up things. So I'm okay with taking a little bit extra or maybe unnecessary steps in order to move the community forward and have the page with all the Redfish commands that we are mandating versus, optional ones, and all the properties with CLI or other tooling, giving a good examples how to use them, so people that order DPUs today can start playing with them and see that it's working for me on NVIDIA Bluefield versus Intel Mount Evans versus AMD Pensando card and Marvell and others. I see it's working. The same commands can work for me. They feel much more comfortable moving forward. And then we can remove the example commands once we find a good alternative for open tools and open ecosystems, and just point to them and say, yeah, we integrated with this system, or integration already exists with Ironic and others. So we can just add links and point instead of providing the examples. I hope that makes it a little bit clear, my view on this, and you can obviously disagree for sure.
No, I agree with you. It's just what the point I'm trying to raise is the group needs to make that decision at some point. And that's all I'm advocating.
Yep.
One thing that I'm curious about the Redfish part, we did talk about that everything would be controlled from the platform BMC, from the server BMC. So we won't rely on things like DPU BMC and stuff like that. So do we need to define a completely new scheme here? Or
Yes, I think we do. We have two options, or two even modes. Even there are official modes or unofficial modes, but I think we have two options. First of all, is everything controlled from platform BMC or server BMC? And the other option is we do see some customers, large ones or more adventurous ones, moving into standalone management systems from DPU, viewing DPUs as servers, and want to manage them as servers independent endpoints. So they will just come in out of band to the AMC or DPU BMC, either through Redfish or whatever spec we come up with, and control them directly from the orchestration systems. So I do think we have two paths in our hands. One is said controlling everything from server or platform BMC versus controlling everything from remote management orchestration system.
I very much agree with you, and probably those Redfish paths will change between those two modes. Just because I think that if you are controlling it through platform BMC, it doesn't exist at the moment, but if you're controlling it directly from the DPU, then you can use existing schemes.
So just to clarification, the page that I started, the Lifecycle MD, with all the Redfish examples, are intended to be used as directly out of band from orchestration systems to DPUs, and not intend to standardize or give any examples for platform BMC to DPU at all, because I'm not even sure that Redfish is a good interface to use there. We have a lot of DMTF standards, we have PLDM, we have a lot of things going on there. So I'm not sure if Redfish is even applicable. So just to reiterate, the example that you see is for managing DPUs as standalone entity from external orchestrator.
Possibly the question for the DMTF is more, and actually, I guess the hardware vendors, is the system within a system to be listed under the systems endpoint for compute systems or computer systems in the Redfish API, along with the main host itself, or not?
That makes a lot of sense for me, Julia. Yeah, utilizing what DMTF already did for extending the Redfish to the compute system inside compute system and exposing that from the main CPU controller. This is approach at least we at Dell thinking about taking. So for me, as a server vendor, it makes a lot of sense going that direction. But it doesn't specify the interface between the platform BMC and DPU still. It only talks about how we present the models externally through the platform BMC or server BMC Redfish as a system inside subsystem. We can do whatever we want from interface between the platform BMC and the DPU card itself, as long as Redfish presentation to the customer is, as you said, subsystem inside subsystem.
Okay. Yeah, I'll go with your permission. I'll go over to the boot sequence part. If we are comfortable with it, if you think that there is enough to dig into right now, and it's a no topic, we can continue. Okay. So I'll share my screen. This is basically where we left off the last time. I haven't pushed it as a PR yet because there is not much in here. And Boris, I think that you weren't on the last call. Lee represented Dell, but it's nice to go over things. So basically what we did here is clean up the parts that we said that we wouldn't go into support, and try to drill into the proposed diagram a bit. So the proposed flow was that everything receives power at once, basically. Then we read the full table, understand that it is XPU device, do all PCI enumeration until we get the boot status, basically, that is reported as ready. There is an optional discovery command that we listed here. Honestly, it was kind of to report back devices of parts of the device and stuff like that. We haven't really into that one. I'm not sure that we want it eventually, but just because we skipped it for a later point. And then we landed on the get boot status command, which we said that we would want to extend. Now, from your previous document, you listed here we did land on PLDM. From your previous document, we stated that those current states. And one thing that in NVIDIA, at least, we drilled into a bit is regarding what would we want to extend in PLDM to represent the boot progress by the get boot status. So this is our proposal. Of course, it is something that we should talk about, vote on eventually, within the team. I'm not sure we want to raise it to the larger forum, but when we reach an agreement, I guess we can take it with PLDM and promote it there.
Yeah,
so
I want to second that. Anything that we do on extendal of PLDM, we should as soon as possible reach out to DMTF PLDM team and say that we're exploring SmartNICs. DMTF already know about SmartNICs, so I just want Gal maybe to move faster on initial engagement with the DMTF team to say that we're working on proposal, and maybe they will have even some resources to help us identifying what we need and merging them to the DMTF even before we do this work in OPI. That's my suggestion.
Yeah, so we did sync with Yuval on this one, and Yuval is doing PLDM. It's part of PLDM, so sharing PLDM. So and Yuval is from NVIDIA. So yeah, we did sync with him internally on that one, just to get his point of view of things, and he looked at this proposal and said it's okay with me, but yeah, it's just an initial probe, let's say.
Yeah. So we need to ask Yuval to bring it to PLDM next meeting and discuss it. Yeah, sure.
Mm-hmm.
Yeah, I was curious if you've all had like a presentation on something like, because I think PLDM for NIC is really just a white paper, right? It's a documentation on how you do that as more than a standard, right?
What do you mean?
I don't know. Well, so anyway, I look at the PLDM for NIC document, and it's many technical pages. It's really kind of hard to get the architecture back out of the document, if that makes any sense. Like, okay, so how would we do something similar for DPUs, right? That would really kind of unlock managing them through PLDM, right? Because we want to define a couple extra state sensors. We want to make sure that we have all the states, right? It seems like we just need a couple extra attributes to unlock these workflows, but we just need to define what they are.
I honestly, I'm not sure that I understood you. So you're saying that
so
PLDM,
Gal, what Lee is saying is that currently the standard of PLDM is not directly, I mean, we cannot see the benefit of it in DPUs. We need like extending it or providing additional information and associate it to DPU functionality. So I think that the boot status that you are currently showing, this is like the first stage toward adopting PLDM more widely in the DPUs.
Okay, I see. Thanks for explaining. So yeah, I guess you're right. I mean, there isn't anything specific to DPU in PLDM or XPU. And whether to extend it or have it as a separate topic, I think we can leave it to PLDM if you want to do it specifically for DPUs or not. But this is like how a device reports back its boot progress in general to PLDM. So if that device is an XPU, you can report all states.
Yeah, to me, it seems like there's, in kind of what I was showing in that thing, is there's going to be multiple state sensors, right? There's going to be multiple things, and we need kind of like an overarching, like, this is the behavior. Like, how does this thing behave? Like, how do these states interrelate to one another and be able to make, how do the things coordinate using potentially multiple sensors, state sensors, right? How do we actually sync the platform BMC or the platform up with the XPU?
You basically want to understand how the platform should react to each state,
Mm-hmm. Yes.
Yeah, the behavioral part of this. Yes, I agree. Also, Lee, I wanted to ask you, let's say we make the proposal and we extend it with PLDM. Like, from your perspective at Dell, this is something we are going to implement across DPUs, right? Just to make sure we're on the same page.
Yeah, I mean, it would be nice to have a standard and not have to have custom code for every single one. Also, you know, it's some customers are wanting to embrace more and more OpenBMC, right? So it'd be nice to have, you know, open code everywhere that could support DPUs.
And this is in ways to the NCSI that we're using today, just to make sure I understand.
Yeah, it would replace, because it would be hard, it would be very difficult to drive standardization, I think, around NCSI, because that's, Dell's done a lot of work there, but I'm not sure anybody else has.
This is Reza. It's very difficult to do that. It's not really scalable in the way we get NCSI to a DPU. There's lots of limitations around that. So we'd like to move away from NCSI.
Mm-hmm. And just one last question. In the next PCI Express Gen 6 with the gold fingers on USB, the proposals to use PLDM over MTCP over USB?
I think that's desirable, yes.
Okay.
When we have USB, even currently it's not supported, right?
I heard Bluefield 4 is going to add it.
The Bluefield 4 is in a lot of time. It's not tomorrow.
Bluefield 4 has everything, every feature you can want.
Just imagine. Sake of magic. Okay.
Is that going to be like ConnectX? Is that ConnectX 9 based here?
Well, just pick a random number.
Okay.
And we'll make it work. Yeah, let's
go over
yeah, okay. So what the key takeaway you get from here is that we don't only want to go over the definition of each of them, we also want to understand, to define basically how the server should act on each of them. Now, I'm wondering to myself if this is
Yeah.
something that should be defined in PLDM, or is it something that we should define here in OPI? How the server should act on each boot state, boot progress, because we query the boot progress. Yeah, go ahead.
Well, I think kind of again going back to what PLDM for NIC did, right? It's like the states were defined in other specs, right? But so if we need to add new states to the state sensors, right? That's good. We can add that to that spec, but then there's like kind of an overall how do you manage a NIC using PLDM, right? That PLDM for NIC spec. So you need like an overall spec that says, okay, this is how it's supposed to interwork, right? So I think you need both. But we could start defining it here and then migrate it into a PLDM. I think it would have more weight as a PLDM spec or as a PLDM white paper is probably what it's going to end up being.
I agree. Whatever we can move from here to PLDM, this will be much better. From the amount of people involved, the amount of involvement that we have, the weight that PLDM and DMTF has versus OPI. I think, again, once we have some initial proposals that we all quickly can agree upon, even with not more details, all of us can join one of the meetings of PLDM that will discuss this addition to the spec. And if we can make it stick there, that will be the best.
Apologies, Boris and Lee, I joined late, but is someone taking the lead on putting the DMTF proposal, or you are asking for volunteers for that?
I think Gal said that Yuval and NVIDIA will take a lead on this.
Okay, perfect, thanks.
Yeah, but we will first phrase it here in OPI to make sure that we want to understand what we want to bring to PLDM, and then we'll take it with Yuval and of course internally within NVIDIA to raise it inside PLDM.
Okay, just to be sure, understand the proposal too. This is a proposal to extend the boot progress in PLDM type 2 platform monitoring, or is that defined in a specification? Which PLDM specification are we talking about?
So let me actually check that one. I have it open.
248 and 249.
Which one, sorry?
I posted in the chat, 248 and 249.
Thank you.
Okay, thank you both for that. Okay, now we didn't talk about the other flags that you mentioned there, by the way, so just extending the boot progress one. And I think we can also derive what we are saying here. We should also derive into how to do graceful reset and all those other things, because also in the reset document that you created, we listed there that the two efforts should be, or at least we should aim them to be related. So things that we are using for boot coordination, we should also use to coordinate how a host should manage an XPU on reboot, force reboot, graceful reboot, and so on. That makes sense? Or to keep all that in mind?
Yeah.
Okay. Okay, so those are the states that we wanted to raise to PLDM at the moment. Now, honestly, some of them may be kind of overlapping with the existing states of PLDM that appear in the boot progress. I really wanted to dig into it with Yuval when I'll get the time internally. But if any light bulbs flicks, then just let me know. So the first boot progress state just basically means that the device is powered on, or underwent a reset, and it's just initializing the basic hardware and the first firmware.
Quick comment on that, Gal. It would be really useful to maybe list in in comments what we can assume after each state is available. Right.
Okay, so let's. How do you want to phrase it? State assumptions, let's say.
Mm-hmm.
Maybe we should put it in a table, it will be more clear.
I'll later on edit it, but
Just giving an example for you, like at which state PCI Express machine is up, for example, so we can send something, or just an example, right? At which state networking is.
We can actually divide it into components like networking and so on, but I think the list will go very long if we'll just, but it will be nice to present it as a table. If we eventually land on like several components.
Because like boot stage 1, first mutable code is running, it tells me nothing as a server provider, right? From PowerEdge perspective, from the Dell, what can I do with the device after it reported the boot stage 1?
So perhaps we should not name it state assumption, but state result, because we want to know what happens when that stage is complete, right?
Exactly. Thank you.
Okay. Yeah, makes sense.
And
so
some of them are also for just kind of status reporting, in that it helps in debugging, know where the crash, like what was the last state you got to before it crashed or locked up, right? So that I can find the right engineers to go work on it. Because sometimes there might not be anything different I can do from a platform point of view between like the different bootloaders and such, but I know it may help me know that, okay, maybe it's a problem with secure boot certificates or something because I only got this far in the boot, right?
It's actually a very nice point. Okay. So at the first stage, I'm thinking to myself what we can assume, what we can assume as a result here. I'm not sure that we even have a result here at the end of the day, which we can say this thing is done, other than we get power. What do you think?
I think take it offline with NVIDIA at least, and try to understand what is available after this stage, right? Which machines are initiated, like what we care about, right? We care about PCI Express, right? Or we care about other controls like NCSI maybe, or something. Like just ask what state machines are initiated, and we can go back to this. We don't have to solve it right now.
Okay, sounds good to me. Can take it with the and see what we do on our DPU specifically. The other DPU vendors, do you think you want to take this this list? Maybe I'll post it in Slack and compare it with your existing process and see if it aligns.
It definitely does not align in 100%.
I never
some of
expected
those
it.
states, yes, they are kind of generic.
I actually really try to keep it as generic as I can, so it will make more sense to everyone. But yeah, I think I'll post the list in the Slack.
Two things, Aga. Either maybe Intel, you can come up with alternative proposal, and then we can compare them back to back, or you want to take this proposal and maybe point things that are not common with Intel, because I do want to see both of the proposal and all of us converge together to the same. So if you, whatever time that you have to spend on this, I would like to see either one of those options to kind of see side by side Intel versus NVIDIA.
No problem at all. Majority of them seem very generic, so you really did a good job. But some of them might be specific, and if we have kind of specific like this, I would simply add the ones that are specific to Intel, so that we have a complete list.
Excellent. Thank you.
Okay, thank you very much. So back to the diagram, I think that if we are putting the boot progress here on all, I think until I'll do some internal checking and the other DPU vendors will compare it to their own side. We can start at least discussion about the graceful reset, force reset, graceful reset of the DPU, and how we should handle that one. Now, Boris, I think that you already did some internal work here prior to.
I'm sorry, before you go to that, if you can go back to the diagram, please.
Yep.
Regarding the optional, that optional line there, is there? I'm of the impression that there will be times when the server may need to tell the DPU what mode it wants it to boot into. That is, does it want it to boot maybe into some debug mode, or does it want it to boot into the OS, for instance? And so, how do we clarify that? How do we specify that? Or is that even allowed?
So basically you're saying, as a server vendor, I want to be able to instruct the DPU where to boot from.
Correct.
Things like boot from PXE or boot from a local disk, this is what you mean?
I'm actually more concerned about a debug mode. That I'm assuming that the sort of the domain manager or an infrastructure manager further up the chain is going to tell it which disk partition to boot from. That's probably not something the server is going to know, which boot partition it wants it to boot from. But I'm more concerned about if I have to, as a system guy, if I want to debug this, if I want to debug something, or maybe I want to flash the firmware, those kinds of modes. Will those kinds of modes be allowed?
I agree with Reza. Yeah, that's useful. I think this is what you, Reza, previously stated in a OS boot select register when we discussed option 1 with PCI Express. So similar.
Correct. Yes.
Yeah.
Can
but
you
is
help me
that
phrase
within
it?
that?
I want to check internally what we allow in that regard. So can you help me phrase it again as a question? You basically want to understand how and when in the boot process do we instruct the server should instruct the DPU to boot to a debug mode, recovery mode, something like that?
Correct. To a debug mode or a maintenance mode.
I would phrase it in a way that in which PLDM type it falls into, because I'm not sure in which one it would be relevant.
So, yeah, so you could certainly break out into UEFI, right? And kind of hold there, potentially change attributes, things. Right? And then also look at variables there to determine like what was the last reset cause or things like that, right? If you're trying to do some things in the UEFI, right? Now, whether from a production point of view you want people breaking out into UEFI or not, I mean, there's definitely some setting and getting of UEFI variables and all that other stuff. But that there is an ED2K method for doing that with the BMC, right? But okay, you may need to know in boot progress that something is happening and it's holding there and it's not an error, right? Like if somebody breaks out in the UEFI, you don't want the platform BMC to reset everything after 2 minutes, right? Because it thinks you locked up, right?
I also want to point that we're creating here a time dependency, right? If we're doing that. That's the problem I'm thinking about right now. So if we're saying that both server and DPU receive power exactly at the same time and start the boot process exactly at the same time, so it means that any OS instruction, whether to boot in debug mode, DPU cannot just wait for server to configure the boot source or whatever, debug, not debug mode. So it means DPU will start immediately booting into something. So whether you can change it and then reboot it, that's another question, but not for initial boot. This is what I'm thinking, Reza. Maybe I'm missing.
Yeah, that's absolutely correct. That's how we do it today, is we set it and then issue a reboot.
Okay. Yeah.
And the other point to consider here is that if the DPU has a Redfish for out-of-band management, then the boot order can be controlled from there as well. And the Redfish schema defines values like booting into diagnostic mode or diags. So
the question, if you want to rely on user configuring the DPU to boot from a certain in a certain way prior to the server, and then we don't have that problem at all. We are just leaving it to either doing it manually or doing it through Redfish. It doesn't matter how, but you do it prior to the process. Or if we want to say we want to let the server be able to instruct the DPU what to do in the process. Maybe it's just a problem that we don't want to touch.
And the question is, do you want to have both PLDM and Redfish server running at the same time? Or that would be your configuration choice then?
You absolutely have to, Aga. I think we have no choice because PLDM is mainly for the boot synchronization. Redfish is more going to be used, again, by orchestration system for lifecycle and control. So
time,
and we will have to resolve the conflicts between.
I agree with Boris. I think this is a case where the external lifecycle configuration through Redfish may conflict with an internal state control from the server BIOS, and we have to at least document how to resolve that.
Yep.
So running both PLDM and Redfish at the same time could lead to what problem?
Conflict of requests. Let's say server is asking thing and another thing, who is winning.
Yeah. But
you're trying to control this boot.
Is a problem that this is sort of a problem that platform BMCs have to deal with already today, right? Is that you could have an external user through Redfish working off of cached data, trying to say, next boot, I want you to go here, right? And then somebody go in the local configuration, or they go in through the host OS through UEFI runtime and say, hey, boot here next time, right? So now you get two requests to boot two different things on the next boot, right? How you resolve that?
So you need to have a good synchronization in terms of like event management so that you asynchronously can find out that the configuration changed from the other source.
So basically you're saying the last one wins.
Likely. Most tooling and operators don't tend to care it that much, nor have the foresight to go back and check.
Yeah, but then if you have an event or some notification about it, then you do not rely on your cached values, but you can update them.
I mean, even if you requery I think the issue is even if you requery the BMC, it may be presenting cached values that it thinks are still valid, and it may no longer be valid. So unless the BMC is actively checking and looking for a discrepancy. and then eventing upon that, then
Which
I don't know.
BMC are you referring to? The XPU BMC or the server BMC?
Server BMC.
Yeah, we're just kind of stating that a classical problem that exists today would also exist on XP. And maybe we don't try and solve it for right now and just deal with the problem.
I would highly agree with it, just not trying to solve it, in other words.
Okay, so let's comment Reza comment about, let's document Reza comment about having the command to control entering DPU into debug mode and then reboot. And I second the Aga question is we need to find the right PLDM register to use if we are going to utilize that command. And then let's also document Lee concern about the conflict of requests with PLDM and Redfish with a generic problem, and we'll need to figure out as a group together whether we are going to address it or not.
Okay, wrote it down. I'll send a summary after this meeting, and if you have any corrections you want me to make in how I phrase things, please do. I'll take the debug and maintenance PLDM command also with Yuval, and come with a proposal for next week meeting in 2 weeks on that part. And if I'll have something earlier, then I'll post it in Slack. That sound okay?
Yes, thank you.
Perfect. Okay, so regarding this discovery command, you started with it. So we kind of diverged from it. You want to touch base on it on this one? Or are we good here?
Very good, let's continue.
Okay. So in the reboot part, you presented two topics. What happens when the DPU reboots and what happens when the host reboots, basically. And you start going into a bit of details here, but I wanted to reopen this discussion and maybe think about the whole boot synchronization and how does it fit. So when the DPU reboots, at least from what I saw at the moment of using the DPU, the behavior is not always the same. It depends on the behavior that the server wants, not always the same. It kind of depends on how this DPU is being used. It can be a DPU that is being used for things that don't affect the host directly, or the host can live without them. And it can be things like, for example, providing the storage through the DPU, or a critical application that depends on it and stuff like that. My question to the forum is if you want to get into those areas, or do you want to define basically how the DPU should like one behavior for how the server should handle the DPU, and delegate it to the DPU itself, to the DPU vendor itself.
Well, so I think one of the things you run into is who's in charge, right? So does the DPU need to tell the server that, hey, this happened and I need you to reboot now? Or is it, there's some way you have certain communication mechanisms, right? And then what the DPU may be asking the server to do something, or the server may be needing the DPU to let him know that something happened,
right? So that he can do
Mhm.
some action, right?
Yes,
Obviously,
it's
if there's a bunch of device
bidirectional
drivers-
because it's bidirectional. You have cases that the trigger to the reboot is from the OS, and you have trigger from the DPU itself. So
Actually, there are three entities. There's the DPU, there's the host OS, and then there's the BMC.
Mhm.
And there's two-way communications between each one of those.
And inside DPU, it could be AMC or ARM cores, right? As well.
Correct.
So does the DPU know that if it, okay, so the DPU is gonna reboot, right? And it could reboot for a couple of reasons, right? It could be doing some kind of firmware update, it could be crashing, it could be a planned reboot or an unplanned reboot, right? Okay. And then does it know whether or not the host is going to be affected, or does only the host know whether or not it's going to be affected when the DPU reboots? Like who has the knowledge of like what needs to be done and what needs to be cleaned up after this happens?
Well, there are two use cases. One is the sort of Project Monterey use case in which the OS is sort of split between the x86 and the ARM. And those are tightly coupled.
Right.
Then there is the fully abstracted mechanism or use case, sort of in the cloud native architecture type, where the host OS is using a service on the DPU, whether it's some networking service or compression service or whatever service is abstracted on that DPU. And so in that case, the host OS is dependent on certain services being available and probably needs to be notified if those services are going to be unavailable or temporarily unavailable.
Or does it just detect that because of heartbeat failures or something like that, right?
Potentially, yes. But then it doesn't know, is it coming back, or is that,
Right.
just throw my hands up, or do I just wait?
So I would say there's even another case that's even more removed, like something like a distributed smart firewall or something where it's
Exactly.
where it's not, or you have a switch kind of functionality, right? Where the XP is replacing a network appliance or a switch, and it's totally unintegrated with the stack that's running on the x86. Like whatever else is running on the host has no idea that thing's there.
Exactly. Yeah. And then the other piece is, what is the role of the BMC during one of these transitions? If the DPU has to reboot, then what is the role of the BMC?
One topic that I mean, there are a lot of good questions in this discussion, but one thing that caught my mind is that you talked about the distributed firewall and what happens when you actually need an application running on the DPU. The host needs an application running from the DPU. Now, I wonder to myself if this is even something that we want to standardize on, or is it something that we can say in those cases we have a management system around the host and the DPUs, and it's some kind of higher level entity that is aware of the situation and knows that if a DPU is critical for this host operation or not.
Without actually answering your question directly, what I propose to do is that could be a valid answer, but still it will raise a lot of questions. So at least we need to document that In those cases, we have this kind of assumption. So we have a paragraph that states we have all these use cases, and this use case we don't address because we believe there is an orchestration system that does coordination and we don't need to resolve it. At least documentation is important part. And I'm not saying if I agree with you or disagree with you, but I'm saying if that is a valid answer, it still have to be documented.
Okay. I see. So maybe we should start this by defining the use cases of DPU reboot and trying to go over them like one by one and see how does it affect. So a critical application on DPU is one thing. A storage from the DPU is another thing. A general question of what happens when the DPU is rebooted gracefully, or what happens if you like yank the power from the DPU?
Yeah, I think it comes down to whether or not a particular failure causes a cascading failure, right? So, like if you have a software implemented PCIe control plane, right, it's inherently going to cause PCIe problems that are seen at the host when that reboots, right, or comes down. So it's really about, and you can have a situation where, let's say, you had an edge compute node and the only network connection was going through the DPU, right?
Mhm.
Then you'd have to react. You'd have to make decisions locally. If you have independent management of the two devices, or if you have multiple DPUs in the system, right, and it's a redundancy kind of thing, then that's a different way of managing the failure.
While that's truly, but I just want to caution you about the speed of error propagation. You will start seeing PCI Express errors from the application perspective well before you can read any status or communicate with any of the devices.
Mm-hmm.
So it's good maybe only for later investigation, core dump collection, stuff like that. But just want to be cautious about depending on the real-time status and progressing for making any kind of decisions, probably. Maybe it's not true from the platform BMC perspective. Maybe platform BMC will do polling so fast, which is not the case.
Yeah, don't count on that.
Yeah, exactly. So maybe once a second, once a minute, this is what we say talking about, and then can make harder decisions. But usually what we need to figure out is, though there are going to be unmanaged cases when somebody yanks somebody from behind you, from beneath you, and you need to deal with it well before you will get status update or something triggered.
I would also recommend that we view it in a case where there is no external system that can remedy the issue. For example, I've had calls with folks planning single machine edge appliances, and they actually want to use some of these sorts of cards and devices, and they also want to have BMC access. And I finally explained to them, no, you're going to have one network port. No one's ever going to give you any other additional network access in an appliance configuration. So do what you can with what you have, but don't try and basically boil the ocean for capabilities. In other words, keep it as simple as possible and don't expect to have the fancy features.
Yeah. But it means that you have to have some local orchestration, because if you go in over shared LAN and tell the BMC to do a firmware update on the DPU,
absolutely,
it's not you're gonna lose communication for a while. So you have to make sure that whatever state it comes back into something that you regain control.
Absolutely. And in fact, in the entire thread of discussion I've recently had in that, I basically said, look, you're in the territory of custom solution development. You are going to have to navigate your exact cases, and you're gonna have to have an operator and some code to figure that out and navigate it. Because no one else is gonna use that same pattern. It's situational at that point.
Okay. I know that we are out of time. Maybe we dug into this this DPU reboot a bit late in the conversation, but the discussion gave me a lot of talking points, at least internally. So I'll try to write the summary after this meeting is done. Please let me know if you think there's something that should be rephrased. And next week, we are going to continue about the redfish part and that we did last time. And in 2 weeks, we are going to return to that topic. So in case, so please try to work internally and figure out what you would want to promote from the server side, from the DPU side, on DPU reboot, and what cases are you currently hitting and want to resolve and promote within OPI. And I think that alone could fill up an entire hour or two. Thanks everyone for joining.
Thank you. Bye-bye.
Goodbye.
Thank you. Bye-bye.